So now let's talk about a couple of ways that the firm with market power reacts to different situations. First, let's talk about an increase in marginal cost. So the uh, prompt here is talking about suppose that there's an accident at a factory that Apple uses to get its parts from for the iPad, and so Apple's cost of production increases from $200 to $250 per unit. How does this affect Apple's production decisions? First, uh, marginal cost will increase. That's sort of stated there in the prompt, rising from $200 to $250 per unit. Because we're dealing with Apple, which has market power, uh, they have a downward sloping marginal demand curve, and so the new optimal production should decrease and price will increase. Let's look at this graphically. We have the regular monopoly situation where we have this flat marginal cost curve. This is before the supply accident, before it becomes more expensive to produce. We have the market demand curve, and then we have Apple's marginal revenue curve. Apple produces at the quantity where marginal revenue equals marginal cost, so point A here, and they price not at 200, but at 600. They trace up to where the quantity goes on the demand curve and charges that price. So now we have this accident that raises marginal cost from 200 to $250. We still want to have an equilibrium point where, or a profit maximization point, where marginal cost equals marginal revenue. That's this point C. And then we trace up to the demand curve to point D, and we have a new higher price. Okay, since Apple has a market power over Apple or iPad pricing, they're able to charge a higher price and produce fewer units uh, after their marginal cost increases. What about change in demand? Suppose that for some reason there's an increase in the demand for iPads. This is saying in the medical industry there's greater use for the iPads, so demand for iPads overall increases. Mathematically, we're going to run this through instead of looking at the graph. I recommend before going through this that you look at the example problem from chapter 9.3. So we have the quantity, Q equals 280 minus 0.2 P. We have to find the inverse demand curve. Remember, that's just flipping this first equation, Q equals 280 minus 0.2 P, and solving for P. So to find the new profit maximizing price quantity combination, follow our three-step procedure. We have our inverse demand curve here. We want to find the marginal revenue. We're substituting in 1400 for A, and we're substituting in 5 for B. So marginal revenue equals 1400 minus 10Q. We want to find the output quantity. How do we do that? Always, no matter whether we're talking about a monopoly or perfectly competitive industry, we set marginal revenue equal to marginal cost. So we have this marginal revenue equal to 200. That's our marginal cost. You solve for Q, you should get 1.2. We're dealing in millions of units here, so 1.2 million units. Last thing, we want to find the profit maximizing price. Before, at the beginning of the problem, we assumed that it was 600. All we have to do is go back to our inverse demand curve, plug in our 120 that we just found for quantity, and we should get a price of $800. So importantly, an outward shift in demand increases both the quantity of iPads and the price at which each is sold. So Apple is making a ton more profit from an increase in the demand. Uh, Finally, let's talk about changing price sensitivity of customers. This is sort of getting to the elasticity of demand. What happens when Amazon introduces a new tablet? Demand for iPads should become more elastic, and the demand for iPads should have a shallower slope. Going to our graphs, we have the perfectly competitive case on the left-hand side and the market power case on the right-hand side. We have our equilibriums. First, we say that even if demand becomes more elastic in the perfectly competitive case, it doesn't matter because the shape of the demand curve doesn't matter. Only the intersection with the supply curve matters. So demand can become flat, doesn't change the price and quantity combination. Over in the perfectly competitive side, though, we have this marginal cost equals marginal revenue equilibrium point to start. But when the demand curve becomes flatter, the marginal revenue curve becomes flatter. And so we have a new equilibrium, MC equals MR, and a new price. So price price decreases, and the quantity demanded, or the quantity supplied, increases.